welcome. This is specification by example. You know about constraints, right? What happened if this bottle was filled with water and I turn it upside down? There's something constraining the water from flowing freely. What's that?
Yeah.
The bottleneck, right? Yeah, the bottleneck. So, any ideas on how to improve flow of water? What could we do?
Spin it.
Oh, you too early, man. We could crush the bottle. That's a good idea, but then we can never use the bottle again. Maybe we could drill a hole in here. That sounds pretty expensive. Or if we've been to a technical university like Per has, we could maybe spin the bottle. Like that. You know that? If you take a bottle shaped like this and you spin it, then there's a vortex created inside the bottle that actually pulls the water out of the bottleneck. That only works with water and no other beverages, all right? You heard it here first. So the thing is, it's the same bottle, it's the same water, it's the same us. Just working a little differently, right? So let's see if we can find a way to put that together. My name is Marcus Hammarberg. This is how I look in a drawing. I work for this place, Aptitude. I have one wife, 2 hobbies, 3 kids. I've been a programmer since 1998, mainly on the Microsoft stack and on the web end of it. But the last 8 or 9 years now, I've been more and more interested in how you work effectively together with agile methods such as Scrum or Kanban. Oh, how did that end up there? I'm so sorry. The best book on the topic is soon to be released. So the reason for these presentations that we'll be giving this week is that I'm moving abroad, and I have an idol called Jerry Seinfeld that he did a tour where he told his jokes one last time, because I've been giving these presentations quite a lot, some of them over 50 times. So I'm starting to feel that I'm ready to do something new. So I'll be giving this presentation for the last time, and then I will talk about the topic, but never in this way again. And I'm moving to a town in Indonesia called Bandung, where I'll be working for the Salvation Army soon. We're still waiting for work permits. All right, back to the topic at hand. So this talk is actually based on ideas from a lot of other people, but the thing that I mentioned in the beginning there about constraints can be found in a great book called The Goal. It formulates the theory of constraints. That's the Bottleneck Theory. And simply put, you could say that Elijah Goldblatt says that every system has at least one constraint that constrains the production in some way. So that could be a machine, maybe. In the case of the bottle, that was easy to see, right? It was the bottleneck that constrained. If we didn't have any constraints, then production would be free and as much as we needed. So what you want to do is to tackle your biggest constraint, because that constrains your system the most, and if you fix that one, you have made a great improvement for your entire system. And in a factory, or in the case of this bottle, it was quite easy to see the bottleneck, right? In a factory it's easy to see as well. Maybe a machine is the bottleneck. Then we have a lot of things that are waiting to be processed by that machine. And on the other side of that machine, nothing is happening, because we are all waiting for that. But where's the bottleneck in system development? Any ideas?
Could be requirements.
Requirements, maybe? Test. Interestingly enough, tests often get blamed. We'll talk about why in a moment. Handovers. Good point. How about programming? Anyone? No, never programming. Yeah, all of those might be right actually, but I think that all of your suggestions actually has to do with that. I think that the bottleneck is something a little bit more meta. I think that it is the things that we don't know yet. and even worse, the things that we don't know. And that's too much for my head, so let's take a little example. Think back of your last project. Let's say that it took you a year to deliver that project. And the day before you were done, next morning we're going to the office and we're going to give a big presentation and it's delivered. So we go to the office, but sadly when we come there, this is all we find. This is actually a picture, it happened in Chile. Scared the living daylights out of me. Sinkholes. So there's nothing left. The whole office is gone. All our servers, everything is gone. Our Kanban boards even. So of course the boss says, well, do it again then. How long time would you take? You took 1 year the first time. You have to redo the system exactly in the same way. Will it be faster? How many for faster? Yeah, right. How much faster? Half the time? Less than half the time? Yeah, I think so too. Maybe 30%. Most people say 30 to 50%, and then there's always some wise ass that say, it will take the same amount of time because they've changed everything. But this is a theoretical example. So let's say that it takes 30% of our time. Why? What did we do the first time around? Why did it take so long?
We learned.
Yes, exactly. We learned. We did some things wrong. We thought that we knew how it should behave, and we did that, and then it turned out that it wasn't that way. So, software development to me is learning. So we would like to have some kind of way to form our process so that we find out the things that we don't know yet earlier. That's been called deliberate discovery by a man called Dan North, and he coined the phrase behavior-driven development also, that you might have heard about. And one really good way of doing deliberate discovery is to do specification by example, found in this book by the Bond villain Gojko Adzik. The great thing about specification by example is that it isn't a process. It's a bunch of stuff that people do that are successful. So he called them patterns of working, ways of doing it, and you will see soon what he means. That's really good news for us, because that means that we can apply these ideas to whatever process we're using right now. We can do some of it, we can do all of it, we can do just the beginning or maybe just the end, and start where we think we have the most bang for the buck. So, and my last thing before we start to dive into this is of course not a silver bullet, but it's a good start. I found great use for this, even just implementing maybe one of these ideas. I've learned a lot from it, and I've got a lot of gain from that, both time-wise but even quality-wise as well. So, in the book, Gojko has a really nice map that I've got permission to use for my slides. Thank you very much, Manning, for that. And it follows this route that you see down here, but please don't confuse this by doing all this first, and then we do all of this, then we do all of that. That's called waterfall. We tried that, it didn't work. So we want to do quick iterations through this, of course, as always. Let's zoom in on the first one and see what that is. He talks about deriving scope from goals, from business goals, from the business goals, and get the scope. And what he talks about that is, what should we do? What is we should do? So, am I among geeks? What kind of plane is this?
F-16.
Yes, awesome, thank you. I actually once used a picture on F-18 and I got bashed for that by an audience member. So this is an awesome plane made in the early 70s. When the US military asked for the McDougall Duel, I think they are called the people that makes these, when they ordered this from them, they said, we want a plane that can travel twice the speed of sound. In the 70s, that was pretty fast. And if you built a plane like that, it was really hard to maneuver. And it was a lot of things was really expensive about doing that and risky. So they didn't want to do that. So they did an excellent thing. They went back and asked why. And the answer was, of course, obvious. Well, we would like to not get shut out of the sky, please, if that's at all possible. So now they didn't end up with a plane that could actually go twice the speed of sound. This plane was, even in those days, it was pretty slow, actually. But it could maneuver much more agile than any other plane at the time, and even today. It was the first time that you have a hood like this. So it was glass all around you, so you can look at that at every angle without being obstructed. And if you take a really close look, you can see a little hood up before him there, where all his measurements and gauges and everything is projected. So he doesn't have to look down; he can just look forward. There's a special chair and a special suit for him to make really sharp turns and withstand the high G-forces. All of that is created just so he can maneuver better than any other plane, just so he can not get shut out of the sky, right? But they didn't get twice the speed of sound, and that was what they asked for. So, who really decides what we're going to do? The customer does that, right? But are they really the best ones? So one way, and this is a little sidestep from this, to do this is to check in something called impact mapping, also by Gojko Adzik. In fact, I'm a fanboy, as you hear. Impact mapping is really good because that gives you a nice graphical way of illustrating why you're doing something. So this is the Formula 1 team. Why? Because we want to win the Formula 1 Cup, right? Who can help us do that? Well, the mechanics, of course, and the driver. How will the driver help us? Well, he will drive the car faster, all right? And how will the mechanic help us? Well, he can probably fix the car or trim the motor and do things to it that make the car go faster. Here are software features in our gear. So we have a lot of things, and these are very volatile. They move a lot, and they might be changed a lot. But the nice thing about this is that you can connect back to the goal. Why are we doing this? I heard a story about a Formula 1 team actually that evaluated every idea they had against, does it make the car go faster? I think we should have more commercial on the car. Okay, does that make the car go faster? And the idea is not to answer yes to that and then you can just go. It's the reasoning behind. Why do you want to put more stickers on the car? Well, that attracts more. That makes the car look cooler, and that attracts more better mechanics maybe, and they might make the car go faster. Okay, I like that reasoning. Go for it. Does it make the car go faster? Ask yourself: do we have a "Does it make the car go faster?" question in our project? It's not that easy to find always. So we don't want to let the customer constrain themselves. Right? We want to ask them, why do you want this feature? And we want them to help us understand the business goals for having these features, right? So we derive the scopes from our business goals. And it all ends up in us wanting to build the right thing. That's much more important than building the thing right. Okay, so that was the first pattern, and that help us find, I talked about the constraint, we don't know what we don't know yet. It helps us give a good solid foundation on why we're building this thing in the first place. And as you hear, this is just maybe an idea, a question, a pattern that is really easy to implement. It's just a conversation. So let's dive a little bit more, because the teams that Gojko had interviewed as he made this book, they did something else that was very successful, and that was that they specified together. The worst kinds of specification I get are the one that one day just lands in my lap. Here you go, implement this. That's a really great way to make me feel hostile against that. You know what I do? First thing I try to find errors. Oh, this will never work. I met people like that actually. That's read the specification. Oh, this is so wrong. I won't feel connected to this specification at all, and also after a while I probably put it aside and just code what I think is the right thing. Maybe I have a test specification. I'll use that instead, right? So instead, it would be great if we could get a team of people together to discuss the requirements together, and then we can have all the competencies. These are just 3 examples. Maybe business, some developers, a tester, maybe operations, maybe someone else that is interested. How about the customer, the end customer? Could we talk to them some way? And you see, they bring. I drew this picture. They bring their stuff, their knowledge here. So this is the reason why we're doing this and what we aim to get out of it. What kind of frameworks do we have in our system right now? Have we built things like this before? And the tester might think about, how are we going to test this? Is this testable? Can we change it so that it becomes testable? Can we make smaller parts? And they meet up together and create maybe user stories and examples. We'll take a look at that in just a moment. And we want to do that just in time, just before we start to do development, because requirement has a tendency to rot pretty fast as well. If I write a requirement today and put it on the table here, who would dare pick it up in just 3 months and start working on it? I wouldn't. But I have been handed requirements that was 1.5 years old. That's just crazy. So we want to do it just in time instead of making a stock of requirements just in case. Because doing so gives us opportunities to choose path at the right time, when we have the most knowledge, when we know most about what we don't know yet, right? Another thing that they do is using examples. Natural language that I talk to you today is very good to confuse people with. It's ambiguous and contextual. And a good way to see that is the reason for us having to invent smileys. Smileys was really early in when we started to use emails, and I think BBS is even before that. You know about that?
Yeah.
There were smileys at BBS. And why do we need a smiley? Yeah, because that's how you can illustrate that this is a joke. I just joked with you. Otherwise, Per will think that I'm leaving for early lunch. I'm going at 11. Yeah, that might be true. But we have a meeting at 11. How can he walk in? I put in a smiley, and he knows that. All right. So, read this. What's this? You have to read pretty hard, right? It's much easier now. This is much easier because it's a little example that shows what I'm talking about. In this case, with a picture, that's even better. So a good way of doing examples in software development is to do some kind of prototype, maybe on paper. Have you tried a Balsamiq? Have you seen that site? Balsamiq, awesome site for doing rapid prototyping on paper. And that isn't the completed system. It has a really nice layout that also sends the signal that this is not done, it's just a drawing. So we want to be concrete with examples. And in fact, if you think about it, the first time that the requirement is concrete, that you can say this is the actual way it works, is when it's turned into code. Because that can be, it's 1 or 0. It is this way or not. But we could move that point a bit earlier by using an example. And one way of doing that, there's loads of ways, but one way of doing that is to write a little scenario, like this maybe. Scenario with a name, that's good. The account is in credit, alright. Given the account is in credit and the card is valid and the dispenser contains cash, when the customer requires 50 euros, ensure that the account is debited 50 euros. Alright. This is great. Can you see that we can talk about the system without having to build anything? This is really cheap to change. Everyone can understand this. You don't have to be a programmer to understand it. It's easy to talk about with even business users, with even with technical people as well. And we're starting to create a little language here. Can you see we're talking about account and card and dispenser. Dispenser, just some sort of machine in here, all right. The customer, that's a word that I'm shying away from because there's typically means a whole class of kind of people. Maybe we should have some other word here, valid. This is great because now when I hand this to John, it might be that John is using these words when he programs. So he don't have to translate in his head. Yeah, customer, we call that part in our database because that's more generic. And card, we call that entity, I don't know. Whatever. I've been at a lot of teams where people have to translate between. So after a while, I can't even talk to the business because I don't know what their words means. What did you mean by card now again? Card, that's some kind of server. There's something else in here. We can find functional and logical inconsistencies. Does anyone see something strange on this one?
It's going to make a lot of money to whoever.
Yes. So, did you see? He's debited 50 euro and we're dispensing 40 euros. That looks strange. Oh, sorry, I forgot to say that. But it actually costs money to use my dispenser. So, how much does it cost? We don't know, right? We don't know from this example. It could be 10 euros at time. So every time you use the dispenser, it costs 10 euros. But it could also be 20%. So let's do another example. What if I took out 100 euros? How much would I be dispensed then? Or I might just have been doing a typo, which was the real reason for me putting this up the first time. The thing here that really strikes me is that you're aiming for key examples. And what is meant with key examples is the examples that are enough for us to understand the function. So we don't have to have every single example that you can think of. We just want good enough. Let me see what I have created here. Yes. So, back to this. We just want good enough. We don't need every example we can come up with. And especially if you have a tester in the room, they will, because that's very testable, the thing that we just saw. So they will start to, what if I write the ABC? What if I write null? What if I write minus 3,000 euros? And those are all great examples, but they don't help us understand the function. So let's try that, right? So let's have an example. This is a function. Customer who buys 3 books gets free shipping. You went to Goiko's course, right? What kind of examples would you like to try? Often this ends up with a kind of table. So we have the number of books here and the answer to will he get free shipping. So what's your suggestions? What numbers of books would you like to try out in order to make sure that we understand this function, this feature in the same way? 1 book? Yeah, we could try. Do you get free shipping with 1 book? No. With 2 books? No. 3 books? Yes. 4 books? We could continue here to 100, but that doesn't help us, right? In fact, maybe these 2 are the only ones we need in order to understand that. With 2 books we don't get free shipping, with 3 books we get free shipping. What about 6 books? Do I get some kind of discount? No, it's just 3 books. Another example, to get a loan you need to be older than 18. Age of applicant can take loan. What would you like to try?
17.
17, no loan. 18? 19. Yeah, that may be illustrative, but this doesn't help, right? It's a good test. It's a good test because I don't really know what will happen there. So we might test it, but it doesn't help us understand the feature. And that's what we're looking for right now, understanding the behavior. This is one place where I see people trip up a lot, because we're focusing on test. And that's not what we were talking about here. We're talking about key examples. And it took me a while to understand that, but I now understand why he has that in the center, because that's a centerpiece of knowledge that we're after. Up till now, we haven't talked, and for a while yet actually, we haven't talked anything about technology. When I first learned about specification by example, or behavior-driven development that some people call it, I came from a technology perspective, and I was super excited that you can execute Swedish sentences that we will see soon. But as I've been using this, I also come to realize that in fact these exercises and these patterns that we talk about here is really beneficial, and you can get a lot out of just using those. I coached at Spotify for a while, and we had one team over there that I asked me to introduce them to specification by example. They were in a hurry, so I didn't have time to go through all this. We just ran a workshop. And what we did was that I went into the room and we just drew a table with the things that we talked about like that, and we entered their criteria for how the system should behave. So we did that, and we ended up with a couple of tables. They took photos of them, and then 2 weeks later I went to the team and asked them, "Are you done?" "Yeah, we're done." "Can I see the examples? Can you run them for me?" "Run the examples? What do you mean?" They didn't do anything of this, but they were super happy that I told them about this, because they learned a lot about how the system should behave. And they cleared out a lot of misunderstandings just by using examples. That was the big kicker for them. I'm not saying that you shouldn't do this. This is really important, and we'll talk about why in a moment. But doing this that I just talked about, you can start doing that today, this afternoon. And it doesn't cost you much. In fact, it's just asking the question. Get together with a couple of people and then ask the question, could you give me an example on how that should work? So you mean like this? That's often how I start to do it, and I draw an example table on the board. However, continuing on now, we want to refine the application, the specification, so we get a specification with example. And this brushes on one of the most common questions that I get. Especially when you introduce this to business people, they start to, so you mean that I can write these examples over here and they just implement them? That's good. I'm not talking about that. I'm talking about collaborating. And who writes these specifications are not that important to me, I think. There's a couple of things worth noting. The first part that I've talked about so far, I often do on a whiteboard. And then I take a photo, and then someone in the team write this down. It's often a technical person, and that's because you want to check in your specification together with the code that is realizing that specification. So you're versioning them the same way. So version 1.0 of the specification is version 1.0 of the code. So you want them to have, and that often ends up doing a technical person actually have to write this, because I've tried actually to give a Visual Studio to business people. It doesn't work. Don't do that. There are other tools that helps out with it. Check out Cucumber Pro if you're doing a lot of Cucumber stuff. Another reason for us doing this is that we want to do something called refactoring the specification. Refactoring is a technical word used to around programs often when you do code. And that means changing the internals of the program without changing the external. Or in our situation, that means maybe change around the words without changing the meaning of the specification. And we want to change it so that it becomes a better specification. And here are some things that you should think about. The first one might sound very obvious, but that's that you want these to be testable and precise. You want the examples to be really precise and testable. Maybe when we write it on the board, we end up with something that was really fast and we couldn't really say if that is true or not. So we might have to crisp it up a bit. we don't want to write scripts. You know, click here, then check this button, then checkbox, then click that button, then write this. That's not a specification, because that talks about how the system is built and not what the behavior of the system should be. So don't write about your UI. Yeah, it should be about business functionality, not about software design. A lot of examples that you find especially on Cucumber is about clicking here and when I go to this page and stuff like that. Your business user don't want to go to this page. He has a need that he wants fulfilled. You should end up with a much higher level of your specifications. And tomorrow I'll be giving another talk on how to implement this in code, and then we'll get into that. You want each specification to be self-explanatory, so you don't have to cross-reference a lot of sources. It doesn't say that you have to write everything from scratch in every specification, but you should be able to, if you have domain knowledge, read this document only and understand what it does. So you don't have other places for your rules, for example. And we use the domain language, the way that the business talk about the system in our specifications. The aim of these specifications are threefold, actually. We want a shared understanding of what the business behavior is. What is this feature about? We can use it for testing without automating. Let's leave that for now. We can actually use this specification and just run the system and see if it does what we thought that it did. And finally, it's documentation for us. We can read it afterwards and see how should this behave now again. Here's an example of what I talked about earlier. This is a script. There's one thing that's really good about this script. What is that? And you probably need to be a programmer to understand that.
What on that?
Sorry? There's one thing that's really good about this, and that was what tripped me first, because when I saw this, I just thought to myself, oh my, I can write just a couple of things behind, called step definitions, that actually executes all of this, and then we can run any system in the world just by entering this. So it's really easy to automate this. What's bad about this?
Language.
Yes, language.
That you click login.
Yes, exactly. It's almost impossible to see what this function does, because this is about how we're going to build this system and what the buttons is going to be named. So that's another thing. It's really brittle. What if I don't want to have the login anymore? And here I'm even using the programmatical name for the things behind. That's really bad. What if I change that? So it's really brittle. Here's another way of writing that. The same functionality. The good thing about this is that the business functionality shines through in a great way. It's really easy to see that. And don't worry, if you haven't seen this before, you can use variables for these numbers. You can have a lot of examples if you want that without doing repetitive work. So that's what refining the specification is all about. We want to take these key examples that often is in a quite raw format, maybe even just a photo from a whiteboard. Quite often I end up like that. And then we want to make them a good example with the specification. So what I often do is that we take these, someone in the team writes them as a good example according to all the rules that I talked about, and then we meet again for 10 minutes and we just say, this is what I ended up with, do you still agree with what I said? No, you haven't mixed up those numbers, that's not true. But it's much easier to talk about them. If we do that, we can actually, there's tools now that helps us to automate these specifications without changing them. We can actually run these specifications. And this is where the hair on my arms used to stand up every time I said, let's see, executable specification. So you can actually run the specification and it will tell you if the system is like that or not, by giving you a green or red light. Most test specifications that I have used are a copy of the real specification at some point in time. So someone takes the specification and then I'm going to write the test specification now, and I take it and I change the heading and then I search for it should and replace that with test that, and then I change some other stuff. And the problem is that there are two separate documents that are living separate lives. And I promise you, if you're a non-technical person, if you ask any programmer, what would you prefer, the specification or the test specification? Every programmer will pick up the test specification and run with that. I've done that a lot of times. Just put the specification aside. Because this is often much more concrete, and it's what I'm going to be measured against. So if they are not in sync, I don't care really, because I'm just running with that. And that's why testing often is the problem, because they end up with all the problems that we have done throughout the process. So the problem for them is that they are last. It's not that they are bad or that we are writing crappy code. It's just that every problem that we had during the journey up till then is actually accumulated in their step in the process. I had to redraw this, sorry about that, because I got some feedback on my slides. So I'll tell you later why. If you're doing manual testing and working in an iterative, incremental way, aka agile, you soon run into problems. So the first release, the first sprint, it's really simple to test the system, right? They just did the login screen. I can handle that. And even the second one is okay, but after a while it gets more and more complicated. I had the fortune to sit next to another team once, and one day the product owner came down and said, I need this new functionality. He described it in just a sentence, and then he asked the developer, so how long do you think you can do that? How long will it take? Half a day? Okay, awesome. How long will it take for you to test it? And there were two testers, and I remember they stood for a while and discussed, and then they came, 5.5 days. 5.5 days, how is that possible? Well, we're going to write the test report, we're going to update all the test cases, and they had a lot of things to do, so 5.5 days was reasonable. A lot of that time was spent in regression testing all the other things in the system. They were about here in the process. This is a really scary place to be. It was known as bankruptcy for the development department. I actually met the company that was in their place. That means we cannot develop anything new because it takes so long to test it. They had to shut down their development department for about 8 months to clean things up. They're still in business though. That was my scare you part. Luckily there's tools to help us, and if you're on the .NET platform, that's called SpecFlow, and that was the old logo, and if you're on the other platforms, it's known as Cucumber. And in fact, this is valid. This is a valid text that Cucumber can execute. It's the same text that we had before, exactly the same. Saved the typo, the little example that I used to. So we can actually execute this, and it's really simple, in fact, because every step in our scenario, every line is known as a step, and for each line, Cucumber will call into your code. So you write code that is executed for each line. So it's really simple. This code then, it performs the action to request 50 euros. And there's a whole science about writing this in a maintainable way, and that's what we're going to talk about tomorrow, because that's a presentation of its own. and we're still exploring these ways of writing that. But that is awesome, because now we can actually take the specification that we talked about together, don't change it, and have an executable specification that actually is poking our system to find out if the system behaves in the way that we actually thought. And that is great, because now we can validate the system frequently without a high cost. One of my favorite words is feedback. In fact, if I was made to summarize all agile methods in one word, it would probably be feedback. Because all agile methods has one thing in common, and that's that we try to get feedback as fast as possible and then change the way we work based on that feedback. So if we have these scenarios and we can validate them frequently, we can now get feedback on how the system is behaving. Is it still behaving the way we thought it should? If I change this, will all the other things still behave in the same way? The first day on a sprint, this is a really good way of engaging your business users. The first day on a sprint, all scenarios are red, right? I've tried this a couple of times, and then we start to work. And after a while, Åsa has fixed one of the steps. And the eyes of a business user, when they see one of the lines in the specification, go green. Oh, does that work? Oh, good. You're making progress. Yes, it moves. Just showing that. That's something extra. So feedback is awesome. That's the creator of knowledge. But don't be mistaken. It's not freely. It requires some hard work, actually. And let's go back to this little slide. You remember the red one was testing manually, developing in an agile fashion. The blue one here, that's automating your tests. There's a couple of things worth noticing here. The first one is that the first iterations, and this is an awesome diagram, right? It doesn't have any numbers, so it's always true. So the first couple of iterations is actually more expensive. It's much easier to manually test the login screen than to write an automated test for it. But somewhere in time it will start to pay off, and then it will pay off a lot. But my good friend Torbjörn, he told me that it doesn't continue like this. Or the first couple of times I actually wrote it like this, and that's not even true either. Because this will get harder and harder to maintain. In order to flatten this line out, we need to do something else. We need to maybe we need to structure our system in a way that we don't need to retest the whole system every time we do something. Check out microservices if you're interested in that kind of things. So we're now approaching a really nice place here, right? We have a specification that we can validate almost for free, and it's actually executed against the system, so we know that the system behaves in the way that the specification is written. This is pretty good. Now we can start to have something called a documentation system. That's documenting how the system behaves. So we can read about this is the way that the system actually behaves, not the way that we think it behaves. And that's great, because now we have one place to change, one place to read, one place to test. If you ever worked at a big corporation like a bank or a insurance company, who knows the system, the business rules the best?
Developers.
The actual system rules is known by the COBOL developers. I've been to places, not your place, I've been to other places where there were one single guy that knew that if you got down to the really nitty-gritty of how the insurance policies was calculated, he was the only one that actually knew that. Pretty good place to be when you're negotiating your salary, right? The sad part is that you probably need to restructure your scenarios a bit, because these scenarios that I've been talking about, they're talking about a very thin slice of the system, right? Just this scenario. So if I want to read up on how policy is calculated for an insurance, how fees are calculated for an insurance, then I have to read the 300 scenarios, and that's not going to work, right? So we need to restructure our specifications a bit, and maybe create some kind of summary specification. One of the things that I've heard that really surprised me was about a company called Songkick in the UK. They did all of this that we talked about. They specified together and they automated the specification and they rewrote it so it was good. And when they were done with it, they threw it away. And when I first heard it, I was, what? Because they kept a small subset of specifications that was the core functionality of their business, maybe 50 specifications. And then, of course, if these changed the behavior of that core specification, they changed them. But they didn't go through all the specifications at every regression test. So that meant that they maybe ran through 100 tests each day. The company I last coached at, we had 400 specifications that would never run. Why? Because it took too long. So you need to be mindful about that. And maybe don't run everything through your UI, for example. What you want to end up with is that you want to be so sure of your documentation that that's actually describing how the system is working, not that you have to check with the system, right? So, I talked about theory of constraints with bottlenecks and things, and specification help us with that, to find the things that we don't know yet by having better communication, give us concrete examples that are easy to discuss without having to implement the system, help us with frequent validation, so we actually know that the system behaves in the way that we described, and giving us a living documentation that we can start from when we're designing new features, for example. If you want to learn more, you should, of course, check out this book. It's the reference work on that. He wrote another book before that that's also good to read, Bridging the Communication Gap. And then there's some programming books that's not very important. I would recommend these two, and especially that one. Thank you for your time. This talk is recorded and will be found here afterwards. Hence the English. On your way out, could you please give me some feedback? I'll show you a little board where you can do that. Thank you so much.